We're going to look at example 1 and 2 in your section 3.3 notes. I went ahead at the top of the page and wrote out the double angle identities for sine, tangent, and the three different versions that we have for cosine. So in example 1, we have to recognize which double angle identity we have and try to find the exact value of the expression. So if we look at 1a, it looks very similar to this side. So we're betting that we have the double angle identity for sine. So we can see that theta is 75 degrees from comparing it here. So this is going to be the sine of 2 times theta of 75 degrees. So our job is to find the sine of 150 degrees. Okay, so do this by drawing a picture. So 150 degrees goes to the second quadrant. We're going to have a reference angle of 30 degrees to help us out. Across from 30 is 1. Next to 30 will be negative square root of 3, since we're on the negative side of the x-axis, and the hypotenuse is 2. Okay, so now we're able to find the sine. So opposite over hypotenuse will give us an answer of 1/2. Okay, moving on to 1b. This one is the double angle identity for tangent, okay, which we see at the top of the page. So comparing, we can see that theta is equal to pi over 8 here. Okay, so if we plug theta n to this side, we'll get tangent of 2 times pi over 8. Okay, so that's good news for us. That gives us the tangent of pi over 4. All right, so we can go ahead and draw the picture for this as well. So pi over 4 is in the first quadrant, or 45 degrees. We have 1s for the legs, and the hypotenuse is the square root of 2. As far as tangent goes, what we need is the opposite side over the adjacent side. So we get the tangent of pi over 4 ends up being the value of 1. Okay, that does it for example 1. All right, let's look at example 2 now. Okay, so in example 2, we're given that the cosine of theta is 40 over 41, and we know that theta is in quadrant 4 because of the range that we're given. So I'm going to go ahead and draw that out here. Okay, so theta gets all the way to quadrant 4, so our reference angle theta prime I'll label right there. Since we have the cosine, we're going to do adjacent, so 40, and the hypotenuse is 41. So we need to still find the other side of the triangle, which I'll call y. So by the Pythagorean theorem, we'll have 40 squared, or 1600, plus y squared. Okay, and then that's going to equal 41 squared. 41 squared is 1681. Okay, so we'll have y squared is going to be 81 when we subtract that over. And then when we take the square root, we have to be careful because we want a negative answer. So I have a -9 for our y side. All right. Okay, so now evaluating here, we have the sine double angle identity, okay, which I'm going to copy down. So I have 2 sine of theta and then the cosine of theta. Okay, we can find the sine of theta using our reference angle here. So we're going to plug in -9 over 41. And then the cosine of theta we were actually given, so it's 40 over 41. And then it's just a matter of multiplying to finish. So if we take 41 times 41, we'll get a denominator of 1681. And then the numerator comes from multiplying the 2 and the -9 and the 40. So we'll get -720 there. Okay, for the cosine of 2 theta in part B, it does not matter which version you use, you'll get the same thing. I'm going to go ahead and copy down the first version where we get cosine squared theta minus sine squared theta. Okay, so cosine theta we already know is the 40 over 41. Okay, we're going to square that. Sine theta is the -9 over 41, okay, which we're also going to square. Okay, so we're gonna get 1600 all over the 1681, and we're gonna subtract off 81 over the 1681. Okay, so those should both be 1681. Okay, and then when we go ahead and subtract the 1600 minus 81, we'll get 1519 all over the 1681. That does it for B, okay? All right, for part C, for the tangent of 2 theta, we could go back up here and plug it in, but since we've done a lot of hard work for part A and B, we can use that hard work to help us with C. We have the quotient identity for tangent, which is sine of 2 theta over cosine of 2 theta. Okay, so since we have the answers for that, we can go ahead and plug that in. So we have the sine of 2 theta is negative 720 over 1681. The cosine of 2 theta is 1519 over the 1681. And we can see the denominators are the same, so they will cancel out. So we're left with our answer right here. So our answer is negative 720 over the 1519. And that does it for example 2.